Okay, now we're looking at, there's a third video of exercise 1 on page 71. Okay. At this point we're discussing y is equal to 4. Okay, so if we draw this graph, just going to add on your axis. As you can see, there's no gradient here. Okay, so there's a gradient of 0. I'll show you now why. That's your y and this is your x. No? Where's x4? Sorry, y4 is approximately there. How do you know the gradient is 0? Because if I'm forced to write this in the form of y is equal to mx plus c, or if I should write it in that form, y is equal to mx plus c, how do I get 4 standing on its own there? Well, what is this? This is 0. And when will this be 0? Is where m is 0. Can you see that? So the gradient is 0. Okay. So if we must draw this graph with a gradient of 0, it always has a constant y value of 4. Okay, so let's draw this in this red. So that is y is equal to 4. What if we had to draw y is equal to negative 2? What if we have to draw that graph? Okay, so okay, it's simple. If we negative 2 is here on your y, then it will look like that. You see that? Y is equal to negative 2. What if we said x is equal to 6? Now with that graph, if 4 is like that, we must just extend this line a bit. Again, we're just doing by approximation. We don't make all the dots and strokes and all that. For 6 strokes, and no, just by approximation. If that is 6 on your x-axis, then this will be x is equal to 6. Can you see that? Alright. What if we had x is equal to minus 6? Okay, so if negative 6, we can just look by, again by approximation. So you say negative 6 is about the on your x-axis. Can you see? X is equal to negative 6. There's a constant x value of minus 6. So it will do that thing. Okay. If you are asked to work out these points here, the points of where the graphs intersect, let's look at that points as well. Your x is negative 6 and your y is 4. Can you see? Yeah, what would this point be? X is negative 6 and y is negative 2. What will this point be? Think before I write it down. Yes, it will be 6 and negative 2. What will this point be here? Your x is 6 and your y is 4. So it's 6 and 4. Remember, when you're writing coordinate form, it will be always x and y. Okay? If I had made a mistake, please let me know on that number. Otherwise, these videos are free. Alright, so now we're looking at number 2.19. Okay, so there's 2.19. We got 3x minus 2y is equal to 6. So y-intercept, let x equal to 0. You say 3 times 0 minus 2y equals 6. That falls away, so negative 2y is equal to 6. So y is equal to negative 3. Then we have x-intercept, let y equal to 0. So you have 3x minus 2 times 0 equals 6. So 3x is equal to 6. X is then equal to 2. Okay. Our ruler. We sketch the graph. Draw the graph. Draw a sketch graph. Same stuff. So y x. So y is negative 3. So it will be approximately there. And x is 2. Okay. So there we go. Alright. So now we're looking at number 3. Okay, number 3 deals with the table. I'm just going to cut out the table. Just realize now I have to minimize the copy a bit, but okay. This says the following table shows the linear relationship between x and y. So linear is basically a straight line, so it will be in the form of y is equal to mx plus c. Okay. So what we do is we say, okay, we can choose any two coordinates here. So I'll just choose that one there and this one here. Okay. You could have choose any ones. So this coordinate, remember that's your x and here's your y. So it will be -3 and -1. And this here would be 1 and -3. Okay, remember there's many ways of determining the equation of a graph. Okay, I could have done this using the method we use in number patterns. We could have check the relationship that exists between the graph. There's many ways, as I said, okay, of doing this. This is just this method is it's easy. Well, not easy. It works for all or most questions determining the equation of a straight line graph. Okay. So basically, what I do is I try to use something that could be used for most of the exercises. Okay, or most of the questions determining the equation of a graph. So to work out your equation of the graph, which is y is equal to mx plus c, we need to know what the gradient is. To calculate the gradient is y2 minus y1 over x2 minus x1. Okay. Very importantly, if you make that x1, that must be y1. If that's x2, this must be y2. However, if you had made this x2, that has to be y2. If you had made this x1, this has to be y1. Okay. So what we do is we say, okay, you got -3 minus -1. Okay. You see this negative here? Is that negative there? That negative is from the 1. So you say -3 minus 1 over 1 minus -3. Okay. Which that now becomes -2 over 4, which is -1/2. Okay. So the gradient of this graph is -1/2. So y is equal to -1/2 x plus c. So how do I calculate c? By substituting a point on this graph. Let's go with 1 and -3. We normally use one of the 2 points here. Okay, if the gradient is correct, it will give you the same answer for C for both. If the gradient is wrong, however, it must not give you the same answer. This will be an x and a y always. So you got -3 is equal to -1/2 times 1 plus C. This -1/2, you take it over, it becomes +1/2. So C is going to be -5/2. So what's my equation? Y is equal to -1/2 x minus 5/2. Okay. I think I made a mistake somewhere. So let's check quickly. Okay, I picked up the mistake. Okay, I almost thought I made a mistake. But you see what happens is, no? If you put the x value in, you must get the y value out. So what I did was I checked in my head quickly if that was the case. So it wasn't. Okay, so I needed to find my mistake. So after a few calculations, I saw that the points, because I used this point, okay, and that point, it gave me a different straight line, okay. However, when I used these 2 points and that 2 and that 2, it gave me the same calculation, the same answer. So which means to say this point here doesn't actually conform to the straight line. So that point is not right. Okay? So I'm going to omit that, and I'm going to show you, if you had used that point and this one, it would have given you a different equation. That point and that one give a different equation. That one and that one gives you this equation. That point and that point gives you a different equation. Okay, so what I'm going to do is, I'm going to be nice, and I'm going to do the same calculation but using this point here and that point in the next video, okay?